In this section, we will first be talking about formulas, then we will be talking about percents. To begin, a mathematical model is an equation or inequality that describes a real situation. A formula is a specific type of mathematical model. It is an equation in which variables are used to describe a relationship. Examples that we will be seeing are the distance formula and the simple interest formula. The distance formula tells us that the distance a moving object will travel can be found by multiplying its rate by its travel time. As an example, if you are driving in your car at 60 miles per hour for a time of 1.5 hours, then you can determine how far you will travel by multiplying the rate times the time. 60 miles per hour multiplied by 1.5 hours gives us 90 miles. Okay. And we can see that to see that miles per hour multiplied by hours gives us miles, think of it like this. Miles per hour multiplied by hours. We can think of it as multiplying fractions, so the hours will cancel out and we're simply left with miles. We can also use the distance formula not only to calculate the distance, but to calculate the rate or the time. So, if we travel 70 miles at a rate of 45 miles per hour, and we want to find out the time, then instead of substituting the rate and the time into the formula to get the distance, now we substitute the distance and the rate into the formula, and let's see what happens. The distance is 70 miles. The rate is 45 miles per hour. Time is unknown, so it remains t. We get an equation, but we can solve the equation using our techniques of algebra. So we divide by 45 on each side of the equation, and we get t is equal to 70 over 45. You can reduce that fraction to 14 over 9, or as a mixed number, that's 1 5/9. So your travel time is 1 5/9 hours. You could also do a decimal approximation and say that is approximately 1.6 hours. What if we want to do this repeatedly? What if we are always looking for the travel time rather than the distance, but our rates and our distances are changing? Do we always substitute the distance and the rate in and solve for t? Well, there is an easier way. We could start with our formula and solve the formula itself for t to get a new formula. Then we will need only to substitute the distance and the rate in, and we can just perform the calculation to get t without solving an equation any more times. This is called solving for a specified variable. That is what we do when we have a formula, and before we substitute any numerical values into it, we rearrange the formula so that we have isolated the variable that we will be interested in finding. To do that, we treat the specified variable, the one we're interested in finding, as if it were the only variable in the equation. All other variables we will treat as though they were constants. And then we simply solve the equation as though we were solving any other equation in one variable. So let's look at this. If we want to solve d equals rt for t, then we consider d and r to be as though they were constants, So to get t by itself, we would divide both sides by r. And this gives us t equals d over r. Notice that we do not get a numerical answer. We get another formula. All we're doing when we solve a formula for a specified variable is we are rewriting the original formula in a way that will be more useful to us. A second example. We want to solve this formula. V equals 1/3 pi r squared h. This is the formula for the volume of a cone. Okay, well, there's really not much difference between this example and the previous one because we're only going to be doing a division essentially, although because we have a fraction here, we can get rid of the fraction first. That's one of our options. And remember, the way we do that is by looking at the least common denominator. In this case, there's only one denominator, it's 3. We can multiply on both sides of the equation by the least common denominator. And the fraction is gone. Now we'll do our division. We're solving for h, so we're treating r squared as though it's constant. Pi technically is a constant, even though it's a symbol and it doesn't look like a constant, but it is. And really what we have is this whole thing is being multiplied by h. So all we got to do is make one division. We divide on both sides by the entire quantity pi r squared. And what we end up with is h by itself, and on the other side we have 3v over pi r squared. A third example, solve y equals m times x plus b for m. Now you have to be careful because we often solve for x, but here we're solving for m, so we want to treat x as a constant. Well, what we must do here is, here is the m. We need to figure out whether to take care of this x first or this b first. Well, if x and b were numbers, for example, if we had y equals m times 3 plus 4, then we know we need to get the m term by itself first, so we would have to subtract this 4 from both sides. Alright, so in a similar fashion, we're going to have to subtract b from both sides of this equation before we divide by the x. So subtract b from both sides, and we end up with y minus b equals m times x. Now we're trying to isolate m, so we're going to divide by x. And we get m equals y minus b over